Can everyone see my screen?
Yes.
Okay, thanks. So, hello, my name is Pascal, and I'm the president of UAV Concordia for the year 2020-2021. I am a software engineering student, and this is my third year at Concordia. Online, we have Pierre Luca with me. Pierre Luca, do you want to present yourself?
Yes. Hello. So my name is Pierre Lucas, and I've been with UAE for a couple of years. I just finished my undergraduate, and I'm now doing a master's degree in electrical engineering.
Okay, thank you. So, UAV Concordia. UAV Concordia is a society that builds drones and competes in yearly competitions. So, today's topics, we will talk about our team structure, our yearly competitions, the new skills our new members usually develop, research projects. We'll show you a few interesting pictures and we'll tell you how to join. So this is what our team usually looks like. So we have our president and vice president on top. We have quite a few different VP positions, and then we have our team leads. Next up, our yearly competitions. So UAV Concordia usually participates in two main competitions each year. These competitions usually take place in the summer because drones don't like winter. So first up, we have USC, which stands for Unmanned Systems Canada. It takes place in Southport, Manitoba. So each competition has a few tasks which our drone is supposed to be able to perform. So first off, there's autonomous drone flights. So what that means is our drone has to be able to go from one specific GPS location to another, and it has to be completely autonomous, meaning that we can't control the drone during its flight. The next task we'll talk about is medical package delivery. So during USC, while the drone is flying from one position to another, it has to be capable of delivering small boxes. Then we have remote controlled rover. So on top of having a drone system, we have to have a rover as well, which will be deployed from the drone during flight. It has to be able to pick up those packages and deliver them to a specific place. And some computer vision tasks. So the way the rover knows where to deliver the package this year was through QR codes. So our drone had a camera on it. Our rover had a camera on it. It had to scan the QR codes on the boxes and then pick up read the location from there. Then we have AUVSI SUAS, which stands for Association for Unmanned Vehicle Systems International, and SUAS is a student competition. It takes place in St. Inigo's, Maryland, which is in the US. And it somewhat has the same tasks, but it does have a few different ones too. So we already covered autonomous drone flights. Then we have shape detection. So while our drone is flying over the field, there's these cutouts on the ground, which it has to be able to scan, detect what shape it is, what color it is, what letter it has on them, and then send these informations to the competition server, which is how our entire platform is graded. Then we have in-flight rover deployment. So again, during flight, our drone will have to stop at a specific location and drop off the rover. And then the rover has to drive off to a specific GPS location. Then during flight, sometimes we're also in charge of mapping out the field. So we have to create a 2D map of where we're flying. And finally, we have obstacle avoidance. So typically there's two types of obstacle avoidance. There's static obstacle avoidance, which are fake virtual obstacles. So we are given this information before the flight, and we have to perform all of these tasks by avoiding going through this specific field. And then we have dynamic obstacle avoidance, which is we're not supposed to hit other drones. So then, usually UAV Concordia members learn a lot of skills during their involvement. So the first topic will be software skills. Our members will have to, or will be able to learn programming. So typically we use Python, C++ for Arduino chips, and C#. This last one is a new programming language we're looking to use to be able to use the Unity 3D engine to create simulations before testing out our flight. Then we have communication networks. So since our drone isn't connected with wires, there has to be some way to communicate to our drone and control it wirelessly. So those are software tasks. Then we have computer vision skills involving shape detection. And then another new task we're trying to implement is we're trying to implement machine learning techniques to enhance our performance for shape detection or other tasks. So, Piarika, can you take over?
Yes, of course. So for either mechanical engineering students or people who just want to develop mechanical engineering related skills, we have a couple of things. So first and foremost, as a society, we build, assemble, and maintain a number of multi-copter drones. Doing so requires a number of mechanical skills. And then what we also like our mechanical students to learn and be able to do is to to design 3D CAD models. So that can be in SolidWorks, Fusion 360, even SketchUp, or other 3D CAD software. But it's a very essential skill to be able to take an idea and bring it to a CAD design software and get a 3D model out of it. And one example of a situation where that comes very, very useful is when you want to 3D print pieces to supplement the drone. Often we have to design payloads for those drones, and 3D printing is very, very useful to make small pieces to help attach those payloads or just make them functional. We also use a little bit of CNC laser cutting when the pieces we want to create are flat, so that can be useful. So we can go to the next, yeah. And then for electrical engineering students, we also have a number of good skills. So first and foremost, again, multi-copter manufacturing, assembly, and maintenance. Multi-copters are electronic devices, so it requires some wiring, some connectors, some electronics, and also very important on the multi-copters are the batteries. These are large lithium polymer batteries, and they are relatively energistic devices. So getting some experience handling them, charging them, and using them properly and safely is very valuable. And then in general, just systems wiring is something that can be tricky sometimes. So wire sizing and then connector crimping and soldering. After that, once those basics are mastered, we like our electrical students to do some Arduino electronic circuit design. And then when custom circuits are required, it can be interesting to do some PCB design, which is essentially reducing a mess of wires that you can have on a breadboard to a nice printed circuit board. And then once you have your printed circuit board, then you might be required to do some electronic soldering, which is a different set of skills. And then finally, as Pascal mentioned, since our drone fly, there's no wires, so we need some wireless communication systems. So typically on our drone, we have 3 different channels of wireless communication, and setting up the hardware for that and choosing it when we want to buy new equipment is another set of very valuable skills. Next. All right, and finally, in general, in our society, we operate drone. So drone operation is one other set of skills, which is quite valuable. So let's say you want to go fly a drone for any specific purpose. then you might want to plan your flight. So drone flight plan design is very interesting. First, you might have elements in your flight where the drone's gonna be autonomous, so you have to know how to set that up. This is something you can learn. So first and foremost for that would be knowing how to operate the ground control station software that the drone that we use to control the drone. And then using that software, you might be able to set up flight plans to do mapping missions where you have the drone fly in a certain pattern, and then you take pictures of the ground, and then those pictures will then get stitched into a 2D map. A little bit more advanced, you might want to do photogrammetry, where you do the same kind of flight plan. You take pictures of something, and then you create a 3D model out of those pictures using some specific software. And then sometimes you just want to do a flight plan to fly to specific remote locations, and that requires a little bit more logistics. And now, just knowing how to plan the flight of the drone itself is one thing, but then knowing how to plan the whole flight test, so preparing the equipment, preparing the team that's going to go, preparing the procedures, and then, all that requires a lot of planning skills. So this is something that you can acquire with UAV Concordia. And then once you go on the flight test, it's one thing to plan it, but executing it is another thing entirely. So operation logistics at a flight test is very, very valuable, and it's the kind of skills that can easily transfer to any other test environment. And finally, so in Canada, if you want to fly a certain size of drone, having an RPAS, remotely piloted aircraft system pilot license, can be very useful. So we try to help our students acquire this license on their own. And then they can fly their own drone in a legal manner. Right?
Okay, thank you, Bialika. So I would just like to mention that these lists are not exhaustive. And while they are categorized in specific topics, a lot of our members will have to learn something from all the fields. So, and it also doesn't matter if you are in software, you can do mechanical tasks or electrical tasks. So your background will not matter. It's what interests you that will push you to be able to perform these tasks.